Okay, today we're going to start our algebraic expansion and factorization unit. Now, during this chapter, I want you to focus on our two essential questions. The first one is, how can we use patterns to solve problems in life and in mathematics? And the second one, how can writing an expression in two different ways help us understand it better? Section 2A, Revision of Expansion Laws. The objective for this section is to be able to expand and simplify algebraic expressions using the distributive law, product of two binomials, difference of two squares, and perfect square expansion. So let's start with the distribution law. If you remember from previous classes, the distribution law simply states that if you have a number times by a binomial, you distribute that number to each term in the binomial. For example, if I have a times b plus c, so I do a times b, and that'll give me ab, plus, and then I'll distribute the a to the second term, which would give me a times c. All right, let's try a few. For our first example, our instructions are going to be to expand and simplify. Example A. Let's see what 5 times x plus 2 would equal. Using our distributive law, we have the first term times the first term here, so it's going to be 5 times x. Then we got 5 times by 2, so it's 5 times 2, which will simplify down to 5x plus 10. Example B. This time let's take 3b times b minus 4. Okay, to work this problem, we're going to use the distributive law. So I'm going to take the first term, 3b, and distribute to each term in the binomial. So I have 3b times b plus 3b times a negative 4, which we can write as 3b times a negative 4. Now, simplifying this together, 3b times b is just simply 3b squared, and a plus 3b times a negative 4 will be a negative 12b, and that would be my simplified answer. Example C. Let's take this time negative 3x and times it by 7 minus 4x. But we're going to do the exact same process. So we're going to start by taking this negative 3x and times it by the 7. So that'll give us negative 3x times by 7. Plus our negative 3x times by the second term, which is a negative 4x. So negative 3x times 7, that's a negative 21x. And a negative 3x times a negative 4x will give us a positive 12x squared. Okay, example D. We're going to have 5 times y minus x plus 6 times x minus y. Now we're going to do the same thing as we did in the other problems, but this time I'm going to do the distributive property twice. So let's start with the first one. We have 5 times y, which will give us 5y, plus 5 times a negative x, which is a negative 5x, plus, now we're going to distribute the 6. 6 times the x is 6x, plus 6 times a negative y is negative 6y. Okay, let's clean this up a little bit. So we have 5y minus 5x plus 6x minus 6y. Now we're going to combine our like terms of 5y minus a 6y. So let's put those together. Remember, the sign in front of the term stays with the term. Now let's put the two x terms together. Combining our like terms, 5y minus 6y is simply equal to negative 1y, which we'll write negative y. And combining our x terms gives us a positive x. So our answer is negative y plus x. Our second method is finding the product of two binomials. You might have remembered this as the full method, which is the first times the outer times the inner times the last. Just written out, it should look like if I had A times B plus B times C, that should equal out to be AC plus AD plus BC plus BD. For example 2, we're going to expand and simplify. So let's take x plus 4 times x minus 6. So we're going to start with the first terms. So x times x will give us x squared. And then x times a negative 6 will be negative 6x. And then for the inner terms, 4 times x, which will equal plus 4x. And now we're going to do the last terms. 4 times a negative 6, which will be a negative 24. Notice that we have two like terms, the negative 6x and the plus 4x. So let's combine those two together. So we have x squared, negative 6x plus 4x is a negative 2x. Minus 24. And that will be our simplified answer. And we're going to do the same thing for example B. So we take x times x, which will give us x squared. And then our outer terms, x times positive 7, which will give us plus 7x. And then the negative 3 times the x for our inner terms is negative 3x. And then for the last terms, the negative 3 times 7, which is a negative 21. Again, we're going to look see if we have any like terms, which is the 7x and the negative 3x, and we're going to add those two together. So we end up with x squared plus 4x minus 21. For example C, we're going to take a 3x, and then we're going to times that by 4x for our first terms, and that will be a 12x squared. Outer terms, we're going to take a 3x, times it by 1, that gives us a positive 3x. Inner terms, 2 times 4x, which is equal to positive 8x. And the last terms, 2 times 1, which is plus 2. Again, combining our like terms of 3x and 8x, I end up with 12x squared plus 11x plus 2. The third method of expansion we're going to learn is called the difference of two squares. You'll recognize this because you'll have a plus b times a minus b. Notice the first terms of each of those binomials and the second term of each of the binomials are the same. The only difference is we have one has a plus sign and one has a minus sign. Now if I expand this out as the method we learned in the last section, you'll notice that the two middle terms cancel out. And I'm left with just a squared minus b squared. Example 3, let's expand and simplify. So for part A, we have x minus 3 times x plus 3. Looking at these two, I notice they're exactly the same except for that minus and plus sign in between the terms. So that tells me I'm going to use the difference of two squares. So I'm going to take the first term and square it, which is x, and our second term and square it, which is a 3. So that'll give us x squared minus 9. Part B. Again, notice that the only difference between these two binomials is the plus sign and the minus sign in between the two terms. So this means I will use the difference of two squares. If I take the first term and square it, I end up with 3b quantity squared minus my second term squared, which would be 5 squared. Now using our distributive properties of powers that we learned previously, I will now rewrite this as 3 squared times b squared minus 5 squared, which simplifies down to 9b squared minus 25. Okay, let's look at our last method that we're going to learn in this section, which is perfect square expansion. This is where you have a plus b quantity squared. Now, as you can see from the above work, this just simplifies down to the first term squared plus 2 times the first term times the second term plus the second term quantity squared. For expand and simplify. So part A, we have x plus 2 quantity squared. So what I'm going to do, I'm going to follow this pattern that we have up here, and I'm going to take the first term and times it by itself. So x squared plus 2 times the first term, which is x, times by the last term, which is 2, plus the last term squared. So that would be 2 squared. And now we're just going to multiply together. So that's x squared plus, well, 2 times 2 is 4x, plus, and then 2 squared is also 4. So I have x squared plus 4x plus 4. I'm going to do the same thing in example B. So we have 3, our first term is 3y, so I have 3y squared plus 2 times our first term, which is 3y, times by our last term, which is 5, plus our last term squared, so 5 squared. Simplifying that down, I'm going to have to use my distributive property with my power, distribute to each base. So I'm going to get 3 squared, y squared, plus, now let's multiply this middle term together. I have 2 times 3y times 5, so that should be 30y, plus 5 squared, which is 25. Final answer, 3 squared is 9, so I got 9y squared plus 30y plus 25. So for example C, notice our first term is 2a squared, so I'm going to take 2a squared and square that, plus 2 times our first term, which again is 2a squared, times our last term, which is 3, plus our last term, 3 squared. Multiplying that out, I've got to distribute the square to each base, so that comes 2 squared, and square of a squared is a to the 4th, plus multiplying these three terms, these three items together, I should end up with 12a squared, plus, well, 3 squared is 9. Let's clean up the final first term, so that would be 4a to the 4th plus 12a squared plus 9. For example D, my first term is a squared. So let's take our first term, a squared, and square that, plus 2 times our first term, which again is a squared, times our last term, which is b squared, plus our last term, which is b squared, and we need to square that. Simplifying that down, a squared squared is a to the 4th, plus 2a squared b squared plus b to the 4th. Difference in example E and D is that I have a subtraction sign. So let's start by rewriting this as a plus a negative 7 quantity squared. And then we use the same rules that we just used above. First term squared would be a squared plus 2 times my first term, which is a, times my last term, which is negative 7, plus my last term squared, which would be negative 7 quantity squared. And then let's simplify. A squared, and then we have 2 times a negative 7 times a, so that's going to be a negative 14a, plus negative 7 squared is negative 7 times negative 7, which becomes positive 49. Okay, for our last example, I'm going to start, since this is a minus, by rewriting it as y squared plus a negative 2 quantity squared. And then we're going to use our rule from before. So that's going to be our first term squared plus 2 times our first term, which is y squared, plus our last term, which is negative 2, plus our last term, negative 2, quantity squared. And then simplify. So y squared, quantity squared, is equal y to the 4th. 2 times y squared times a negative 2 is negative 4y squared. And negative 2 squared becomes a positive 4.